method. You can solve them together without separating. Okay, so solving together, now we have minus 1 less than or equals to 3 minus 5x over 2 less than or equal to 9. Okay, so multiplying both sides by 2, you can multiply all through by 2. So this let's see, multiply all through by 2. So we have 2 times minus 1 less than or equal to 2 into 3 minus 5x over 2 less than or equals to 9 times 2, and this will give us minus 2 less than or equals to 2 goes into there, 3 minus 5x less than or equals to 18, and then we can take 3 away. That's subtracting 3 all 2, minus 3 minus 3, and that will give us minus 5 less than or equals to minus 5x less than or equal to 18 minus 3, which is 15. Okay, and then we can divide all through by minus 5 now. Divide all through by minus 5, the coefficient of x, to remove the coefficient of x. Okay, so remember, when you are dividing by a negative number, the sense of the inequality changes. So here we are going to have the sign changing to this 5 here 1. So 1 is greater than or equal to x greater than or equal to minus 3, because here we have minus 3, and here we have 1, and this is 1. Okay, so we can rewrite this answer. So we can rewrite this answer as minus 3 less than or equal to x less than or equal to 1. Okay, and the number line can be given in form of this. Okay, minus 3 is somewhere here, minus 1 is somewhere here. So we have closed at 1 end. The inequality is closed, so we shade the circle. And then we join them together because they are compound, and then we write the inequality on expression here, and this is x. So we can solve it together. Remember, in the first example, we separated the inequality we broke the inequality into 2. In this example, we solve them together. So you can use either of the method. So the next example is solving reciprocal inequality. Remember, the reciprocal property says 1 over a. If 1 over a is greater than 0, then a is greater than 0, or if a is less than 0, then 1 over a will also be less than 0. To solve the inequality, 4x minus 1 inverse greater than 0, and grab the solution. And remember that 4x minus 1 inverse is the same thing as 1 over 4x minus 1. So the reciprocal property states that when 1 over a is greater than 0, then a is greater than 0. We now say since 1 over 4x minus 1 is greater than 0, then 4x minus 1 is greater than 0. So we solve 4x minus 1 greater than 0. So add 1 to both sides, and that will give us 4x is greater than 1. And then we divide both sides by 4. Divide both sides by 4. 4 goes before we have 1. So this is x is greater than 1 over 4. Okay, so we can grab the solution thus. Okay, so 1 over 4 is somewhere around here. So the arrow points to the right and the circle is unshaded because the inequality is straight, and this is the x-axis. So this is how to solve reciprocal inequality. And here, guys, these are exercises. Okay, so on this particular exercise, make sure you try these ones that I'm marking. Try them, they are very important. Very important, guys. very important. So let's try to solve one of these examples here. Let's take 79. X plus 2 into x minus 3 greater than x minus 1 into x plus 1. So the question says x plus 2 into x minus 3 . So we have x plus 2 into x minus 3. Okay, I'm solving 79 greater than x minus 1 into x plus 1. So this is what we have in the inequality, guys. So let us solve this together. First thing, we open the bracket. We open the brackets. We have x squared plus 2x minus 3x minus 6 greater than x squared minus x plus x minus 1. And then we can collect like terms here. We have x squared minus x minus 6 greater than x squared minus 1. And then collecting like terms, guys, let's subtract x squared from both sides, and that will give us minus x minus 6 greater than minus 1. And then we can add 6 to both sides, guys, and that will give us minus x is greater than minus 1. And guys, we can divide both sides by minus 1. And remember how you divide, the sign changes to less than. And this is the inequality, and the graph will look like this. So s is less than minus 1. The arrow points to the left because it is less than, and the circle is unshaded, and this is the x-axis. So it's very simple, guys, very simple. One more examples, and then we'll end the exercise, guys. So let us look at another example of that nature. Look at this example: x into 9x minus 5, x into 9x minus 5. Okay, less than or equal to 3 minus x squared, 3x minus 1 all squared, less than or equal to 3x minus 1 all squared. So solving this, we open the bracket. We have 9x squared minus 5x less than or equal to 3x all squared minus 2 into 3x times 1 plus 1 squared. Okay, and this can give us 9x squared minus 2 times 3 is 6x squared plus 1. So this is less than. Then we'll start bringing the like terms together. So here we subtract 9x from both sides because 9x is common. So, and that will leave us with here we have 5x on the left, and on the right we have minus 6x. And bringing the variables to the right, we can add 6x to both sides. Okay, and that will give us x is less than or equal to 1. Okay, and the number line will look like this. Okay, this is 1. It is less than or equal to, so we shade the circle, it is closed, and the arrow points to the left. Then we can write the inequality on the right, and this is of course the x-axis. 0 is somewhere here, so somewhere around 2, and this is minus 4. And this is the representation of the inequality, guys. It's very simple. So these are the solutions of the inequality. So you can try the remaining exercises, and then see you in the next class. We'll be discussing applications of inequality and absolute value inequality. Bye.